Okay, so far we've been dealing with lovely questions where they draw a diagram for you. Unfortunately, that's not particularly realistic. We need to be able to deal with it where we've got a situation described in words and we have to be able to draw our own diagram. So, a non-uniform rod AB. So again, it's non-uniform, means the centre of mass will not be in the middle. It means we'll have to find that, and that is indeed the question if we look at the end. Centre of find the distance to the centre of mass. So non-uniform rod AB. Let's clearly mark on these points A and B. It's 3 meters long and it has weight 20 newtons. It's resting on supports C and D. So this is C and this is D. And we've got this is 1, this is 0.5 because the total is 3, which would mean that this bit in the middle was 1.5. The magnitude of the reaction at C, so let's switch colour because we're going to start marking forces on, 3 times the reaction at D. So if we call D R, then we know that C will be suffering with 3R. Find the distance of the centre of mass from the rod from A. So let's imagine the centre of mass. We don't know where it is. It doesn't really matter where we mark it on for the sake of this. But if I put it on here, right, and it's a weight of 20 newtons, and this length here we will call our X, and that's the bit we don't know. We don't know how far that centre of mass is away from A, and it wants us to find the rod, distance of the rod from A. So what can we do? Same 2 options as every single question like this. We can resolve vertically and we can take moments about whichever point we want. So resolving vertically gives us that 3R plus R is equal to 20. So that's 4R equals 20 and R equals 5 newtons. Alright, very nice. We then want to take some moments. So moments, and again, it doesn't really matter where you take them. I'm going to do them about A for 2 reasons. One, it's really easy to see which direction is clockwise and anti-clockwise, and the other is look at where my X is. Right, this is from A, the distance is X. If I make and take moments about C, which I could do, then I'd have to do something with the X. What would the distance of C to here be? Well, it'd have to be X minus 1. So we'd do X minus 1 for 20 for that moment. So if you get yourself in a situation where you have to do that, that's fine, right? Because you want to take moments about C. You just do X minus 1 was the distance and then multiply out. Okay. In terms of what we're looking at there, moments about A, we've got two forces pushing them up. Right, so these will be, if we imagine it pivoting about A, we can turn it like that. That'll be anti-clockwise, both of those, and then this one is clockwise. So let's do the anti-clockwise ones first. Right, it's 1 times 3R, which is 15 newtons, right, because R is 5 newtons. And the second one is this one, it's 2.5 times R, which is going to be 12.5 newtons. So these should be Newton meters because they're moments. This is also anti-clockwise. Meanwhile, for the clockwise moments, we've just got X times 20, that's the distance X times 20. So this is 20X Newton meters, and that's the only one clockwise. Now, the question says it's in a horizontal position resting. That tells us that these 2 things are going to be equal. So we can say that the clockwise ones equal the anti-clockwise. So 20X equals 15 plus 12.5. Right, this gives us that X is equal to 27.5 divided by 20. So that's X is equal to 1.375 meters, which we should really round to 3 significant figures, but I can't bring myself to do it because that's just such a lovely answer as it is, isn't it? Right, so 1.375 meters, we'll leave it like that, a bit naughty, but we'll leave it like that's 4 significant figures, and that's the distance of the centre of the mass from rod A, so we need to write a sentence. So the centre of mass, I'll put COM for short, is 1.375 meters from A. Okay, and that's example 10. That brings us to the end of lesson 4.4, so it just leaves for you to do some exercises. Lots of good exam style questions in this one. It is getting a bit tricky now, this unit, I know, but just stick by, draw a good diagram, resolve vertically, and then take moments, right, about any point that you want, right? Any point you want, you can take moments about. So exercise 4D, I would recommend you to do the odds, but they're all really, really good questions and really challenging in some places. So have a go. If you need help, post on the forum.